Yes, dear students, now in continuation of vectors, uh, I have the topic here today, representation of vectors. Vectors, I told in last video that those physical quantities which have magnitude direction or which needs magnitude and direction for their complete understanding, and hence they are different from scalar quantities. Now how to represent them to understand what we are doing. So vectors are represented in two ways. Vectors are vectors are represented in two ways. Number one, geometrically, or I can say graphically also. Graphically. And number two, by using letters A, B, C, D. Actually, some people may write using alphabets. Alphabet is one only which consists of all these letters. And so don't be confused. Now, how to represent graphical representation? Graphical representation of vector. Representation of vector. Vectors. Right? Graphically or geometrically, a vector represented by an arrow, or I simply say by a line with an arrow on its head. Graphically, it is represented, vectors, I should say vectors are represented by arrows or with a line carrying an arrow. For example, if you want to represent force of 100 Newton, for example, force of 100 Newton acting in the east can be represented by a line with an arrow, line of length 10 centimeter, using a scale 10 Newton is equal to 1 centimeter. Alright. And the direction along east. How? First of all, you mark here north, south, east, west. So our force of 100 Newton is acting in the east. So I told you here, take a scale, 10 Newton equal to 1 centimeter. So draw a line of 10 centimeter and write this arrow here on the top of the line pointing in the east. And you can write here F equal to 100 Newton. In the east दिखा रखा हमने. So this is a method of representing vector and length of line. I am telling you, length of the arrow, or you can say length of the line, gives the magnitude. Now I have explained what is the meaning of magnitude. I am repeating again. If I say my height is 5 foot 9 inch, then 5 foot 9 inch is the magnitude of my height. And this height does not require direction. The force of 100 Newton or any other displacement of 10 centimeter or 10 meter or 100 kilometer can be expressed by using scale. Suppose you want to represent displacement of 100 meter, so you can take, let it 10 meter equal to 1 centimeter, draw a line of 10 centimeter in the prescribed direction. Clear? Now bilaterals. Bilaterals. A letter we can represent again bilaterals in two ways. In our own writing, we represent a vector by a letter with an arrow over its head. For example, you write, we want to write force. So we write force by vector F. Force is vector, so we will put arrow here. So this is one method. Once I met a student who prepared for 2 years to compete this PMT exam, which is now called NEET. And the student came to me after 2 years of coaching somewhere else, I don't know. When I asked one thing here, which I am going to tell you, we represent vectors by bold-faced alphabet. Secondly, in some standard books, vectors are represented by bold-faced alphabet. Bold-faced alphabets. Sorry, bold-faced letters. Sorry, alphabet. I'm sorry. We use vectors represented by bold-faced letters. Like force. They make it thicker than other letters and darker. You can see in your book, NCERT book, in NCRT book. Actually, I lost my NCRT book from here. Uh, but I can show class 12 book. They write the bold-faced alphabets like here. They have written this P. Are you able? You will be able to see P. This P is darker than other. Or I will show you it here also. This here in this book, this E, I think clear to you, is darker than other letters here. N cap also different from, have more darker and wider. So in books we write bold face alphabets. But why do we use arrow? Because for us, it is in writing, it is not easy to mark the again dark ink. So we use by using arrow on the head of letter. So this is the method of representing vector in two ways. Right? So it takes time to explain. So vectors are those which have magnitude direction, or simply you can say the physical quantity which need the magnitude and direction for complete understanding. I think you might have got, if I say apply force of 100 Newton on a table. So first of all, it will feel how big force is 1 Newton, 100 Newton. I will make it clear how big is 1 Newton force. In one video based on definition of force, I have explained how big is 1 Newton force. That is another thing. Now, types of vectors. Types of vectors. There are kinds of vector. Here, first of all, I will take null vector. Null vector or zero vector. It appears ridiculous when we tell what is the definition zero vector, or a vector whose magnitude zero. A vector whose magnitude is zero is called zero vector or a null vector. Now, why it is needed zero vector? There is in physics, we write some equation, some formulae. If left hand side represent vector quantity, or I should say they represent work, then right hand side should be also work. You can't say this side force and this side velocity. So if left hand side is representing vector, then right hand side should be vector. If I write vector A R equal to mu A plus lambda B, and here mu is equal to minus lambda. Sorry. If I say vector A or B are there and their sum comes 0, if I write 0 like this, it is wrong to write, because A plus B represent a vector quantity. So right hand should be vector, so we use 0 with arrow over it. So, and simply if I add 0 vector, so it will give A vector. some vector is added to A whose magnitude 0, it comes 0. Mainly 0 vector is defined here just to maintain homogeneity of equation. Homogeneity. Homogeneity of equation. What is the meaning of this? I told you if left hand side is vector, then right hand side should also be a vector quantity. So this 0 vector or null vector fulfills this purpose, so that of maintaining this fulfills the purpose of maintaining homogeneity of equation. So this is null vector. Now number 2, I come to equal vectors. Equal vectors. I told you equal vectors have magnitude and direction. Two things are required for representing vector. So 2 or more vectors which are equal in magnitude and have same direction are called equals vector. Equal vectors. If I write here, this is A, this is B, maybe different, but they have same direction. It is C. A, B, and C. They have same magnitude. Magnitude is the length of line. And if they are parallel vectors, then actually they are called equal vectors. And we can write here vector A equal to vector B equal to vector C. Actually, once in one exam, my colleague asked student in the annual exam to define equal vectors. So first of all, I saw him, so what are you writing? While you asked, was there no any question? But later I found while copy checking, 90% of students could not define equal vectors. They simply write the vectors which have same magnitude. Vector has two things, the magnitude and direction. If both are same, then vectors are equal. Okay, students, simple thing hai. This vector is taught here actually not as a mathematics. It is a mathematics tool for us, and it makes the study simple. इस समय simple होती है physics पढ़ना. Actually, the mathematics which you learn in class 11, 12, this whole mathematics is there to understand physics, to solve the problem physics, differential, integration, trigonometry, algebra. All these things makes our physics simple. We can't understand if we don't know trigonometry and algebra or even arithmetic. Every mathematics is required. By simply initially the arithmetic was required only to maintain the account balances. So that is another thing. But now in physics, you might have seen in many examples we need trigonometry, we need algebra. We will come into that now. Unit vector. Unit. नाम से it is very clear from its name. A vector whose magnitude is 1. A vector which has magnitude 1. A vector whose magnitude is 1 unit. 1 unit. Unit understand na? Like displacement meter. Unit is called a unit vector. A unit vector is represented by a letter wearing a cap. Wearing a cap. वो कैप ऐसे बनाते हैं उसके ऊपर कैप ऑन इट्स हेड. फॉर एग्जाम्पल I write a cap. So here a cap represents a unit vector. Unit vector generally is used to tell direction only. So, and one thing very important here, I should say, this is very important to understand and to learn. A unit vector along a given vector, say P, given vector P, is given by small p cap. Unit vector is equal to vector P upon magnitude of P. If a vector is divided by its magnitude, then we get a unit vector in that direction. Unit vector in that direction. Now in physics, we can use any letter to represent alphabet. So here we use x, y, z axis. x, y, z भी होता है ना? ये x axis, ये y, ये z. So these are three directions also. It is origin here. We write along x axis we use I cap as a unit vector. Along y axis we use j cap, small j, like this, dot लगाइए और cap, j cap unit vector along y axis and along z axis k cap. This chapter is very simple, but I have noticed in my total career, students a little find difficult to understand. Everything which we are learning is difficult. In this age, I myself find difficult to handle this mobile phone. Before going into this, making my video on YouTube, I took the help of my students, which was just in class 12, and he told me everything about how to start and how to upload to YouTube and how to make playlist and so many things. So learning of anything in the early stage appears to be a difficult task. So please students, don't get afraid of learning. You have to work hard. When you go in new city, initially you get disturbed. I don't know which way I will have to move, because there are number of streets, number of ways are there. But you become familiar when you live there for a long time, or you repeat the thing. So repetition makes the thing clear. Now I think it is clear. So I cap, j cap, k cap are the unit vectors along x, y and z axis. In next video I will take some more because this has become longer. Actually I found if you are looking at the video, so you feel difficult to concentrate for long time. So in next video I will take position vector and many other things. Thank you.